In this video, we're going to look at the definitions for an interval where a function is increasing, decreasing, and constant, and then we're also going to learn how to find those intervals. In order to understand the concept of an interval where a function is increasing, decreasing, or constant, we're going to start by looking at the formal definitions. Now, while these may not be super helpful in helping you identify what these intervals are going to be, they are an important foundation for us to use to create more of a working or layman's definition to help us find the intervals. So a function f is increasing on an open interval I if for any choice of x1 and x2 in I, with x1 being less than x2, we have f of x1 is less than f of x2. And so a lot of times students tell me that I sound kind of like Charlie Brown's teacher. I'm just kind of going wah, wah, wah. But what that really means is we can take this interval, and that interval can be from 0 to 2, or it can be an interval from negative 1,000 to a million. But on that interval, we're choosing two x values, x1 and x2, and we're choosing them so that x1 is smaller than x2. So maybe x1 is 1 and x2 is 2, or maybe x1 is 0 and x2 is 5. Doesn't really matter as long as x1 is smaller than x2. And whenever that happens, in order for us to say that the function is increasing on that interval, then f of x1, the y output when we plug x1 in, has to be less than f of x2. If that is true, then we say that the function is increasing on that interval. On the flip side of that, we say that a function f is decreasing on an open interval I if for any choice of x1 and x2 in I, with x1 still being less than x2, we have f of x1 being greater than f of x2. So notice that the only thing that changed between these two definitions, x1 is still less than x2 in both cases, but the outputs, the y values, if the function is increasing, then the y value of x1 is going to be smaller than the y value that corresponds with f of x2. However, if it's decreasing, then the y value that corresponds with x1 is going to be larger or greater than the y value that corresponds with x2. And then, of course, our last option is, what if there's no difference between those outputs? So a function f is constant on an open interval I if, for all choices of x in I, the values of f of x are equal. So now that we have an idea of this formal definition, what's an easy way for us to go about finding these intervals? And I like to think of it in terms of riding a bicycle. So I look at my graph and I say, okay, let's start on the very most left side of the graph and let's think about riding our bicycle. If we were riding our bicycle from left to right, we would start by going downhill. Anywhere that we're going downhill, that would be an interval where the function is decreasing. At this point right here, we would start going uphill and we would continue going uphill all the way until this point. So anywhere that we would be moving uphill from left to right, that would be where the function is increasing. If we are on level ground on our bicycle, that would be where the function is constant. And then here we're going downhill again, so that would be another interval where the function is decreasing. Now, a couple things to remember is that these intervals are defined by x, so we're always going to use the x values to create the intervals. And they are always open intervals, which means that we're always going to use parentheses around the endpoints of the interval. So we'll never use brackets when we're working with increasing, decreasing, and constant functions. So let's start by looking at our intervals where we are increasing. And remember that increasing means, oh, and that's a little large, so let's make that a little smaller. Remember that increasing means we would be riding our bicycle uphill. So how many places on the graph would we be riding our bicycle uphill? Well, we would start at this point and we're riding uphill all the way until that point. Notice that there's a point that's been plotted there in the middle. That doesn't matter. We did not change the fact that we are increasing over this entire piece. So the interval is going to be all the way from an x value of -4 to an x value of 0. And again, remember that these are open intervals, so we will use parentheses around each side. If we look at the graph, that's the only place where we would be going uphill. So that is the only interval on which the graph is increasing or the function is increasing. So now we're ready to look at the interval or intervals where the function is decreasing. And remember, that is where we would be riding our bicycle downhill. So here's one place where we would be going downhill on the graph. Here's another place where we'd be going downhill on the graph. So we're actually going to have two different intervals where the function is decreasing. Again, always go with the x values. So the intervals are created by x values. So we have from -6 to -4. And we use parentheses. And then we have from 3 until 5. So now we have identified both intervals where the function is decreasing. The last thing we need to do is check to see if there are any intervals where the function is constant. And remember, that is where we would be riding our bicycle on level ground. So there is one interval here where the graph is constant, and that would be from 0 to 3. Now, one of the neat things about these intervals is that if we have done our job correctly, then these intervals will span the entire domain of the function. So if we come over here and look at our function, our graph, we see that the absolute smallest x value on the graph is -6. And the absolute highest on the graph is 5. So our domain is going to be everything from -6 to +5. Well, if we've chosen our values correctly, that means our intervals are going to cover all x values from -6 until +5. So we can do a quick check to make sure our answer at least makes sense. It won't necessarily guarantee us we're correct, but it at least will tell us our answer makes sense. And if you accidentally use a y value instead of an x value when creating your intervals, you'll usually catch yourself if you do this little quick check. So we have from -6 to -4, -4 to 0, 0 to 3, and 3 to 5. So again, it doesn't guarantee me that my answer is correct, but it does tell me that my answer at least makes sense.